Okay, friends, this video is to go over the questions on the study guide for the What Do You Expect unit test. Okay, so first of all, we have this first question where we're looking at a bag with marbles. So we want to know the theoretical probability of randomly drawing a green marble from the bag. So the first thing we need to do is figure out how many marbles there are. So 1 plus 3 is 4, plus 4 is 8, plus 5 is 13. So it's going to be out of 13. Okay. And I don't know what I am writing there. And green. So we're looking for green. So the probability of green is 3 out of 13. This next question asks us, if you triple the number of each marble, what will the theoretical probability be of drawing a green marble? Well, if I triple each of these, then I'll have 3 red, 9 green, 12 yellow, and 15 white. Adding all of those together is 39, and there were 9 green. So then question C asks us to compare these two answers to see if they're the same. If you look, 3/13 is the same as 9/39. So because we increased each number by the same multiple, we scaled everything up by 3, our answers are still going to be equivalent. It's just going to be this one's a little bit more. There are a little bit more marbles to choose from. But if you look, for every 3 green, you have 9 here. So 3 times 3 is 9. I don't know where I was going with that, but anyway. Okay, so how many red marbles would you need to add to the original bag of marbles to make the probability of drawing a red marble 1/2? So when you look at this question, when you add marbles, so we started out of 13 and we had 1 red. So when you add reds, you're not just adding to the top, you're adding to the total number of marbles. So if we're starting with 13, I know that half of 13 is 6.5. So I can't add half a marble, but I'm going to just kind of do a guess and check thing and start by adding 7 marbles, 7 red marbles. So I had 1, so now I have 8. And if I add 7 to my original 13, that gives me 20. That's close to 1/2, but not quite there yet. So I'm going to just keep adding red marbles until I get to 1/2. So I'm going to add 1 more. Still not at half. So then I'm going to add another one. Now this is close, but not quite there yet. Very close. So the next one should do it. So as I added a red marble up top, it was increasing the number of total marbles. And here, this is equivalent to 1/2. So how many red marbles did I have to add? Well, I started with 1, and I needed to get up to 12. So I added 11 marbles. All right, next page. A gumball machine contains blue, white, and red gumballs. The probability of getting a blue gumball is 3/8. Probability of getting a white gumball is 1/2. What is the probability of getting a red gumball? So if I know that blue is 3/8 and white is 1/2, since I'm dealing with fractions, it makes life so much easier to have equivalent fractions and equivalent denominators. So, common denominators. Wow. So I can't really turn my 8 into a 2, but I can turn my 2 into an 8. So I'm going to turn this guy into 4 out of 8. So if I have 3/8 and 4/8, what's left for that last color? 3/8 plus that 4/8 is 7/8, leaving me 1/8. So the way that I determine my answer, and on your test, you're going to need to make sure you explain, but what I did was I found common denominators and I added to see what was left. And what I mean by that is I added my blue and white to see what was left for red. So now this is asking us, what if it was 24 total marbles in the machine? How many are red, white, and blue? So I know that my blue was 3/8, but I want to know, well, what if there were 24? So what do I have to do to 8 to get 24? I have to multiply by 3. Whatever I do to the bottom, I have to do to the top. For white, we had 1/2, but we turned that into 4/8. So I want to scale that up to 24. And again, multiply that by 3. Whatever I do to the bottom, I have to do to the top. And then red we determined was 1/8. So 1/8 into, how many 24s is that? There we go. Okay, so now we have a spinner question. So you spin the spinner. Are the possible outcomes 1, 4, and 6 equally likely? So looks like 1 is half and then some. And it looks like there's only one little 6. So they are not, because they don't have equal numbers of spaces on the spinner. Okay, if you spin the spinner 100 times, how many times would we expect it to land on 4? So we need to figure out how much of our spinner is 4. So this half over here has 1, 2, 3, 4, 5. So if we imagined that this half, like that's how we were just dividing up the whole entire spinner, that would mean it was all out of 10. So three of those tenths are 4 on the spinner. So 3 out of 10 was my probability of a 4. What if I scale that up to 100? What do I have to do to 10 to make 100? I have to times that by 10. Whatever I do to the bottom, I have to do to the top. So 3 times 10 is 30. All right, next. To pay you for mowing the lawn, your grandmother puts money in a bag. The bag has 1 $5 bill and 4 $1 bills. You get to draw 2 bills. So start with the tree diagram. Well, we know every tree starts with a seed. If I pull my first bill out of the bag, there's 1 5 and 4 4s. So that gives me 5 possible outcomes at first, right? Then if I pull 5 first and I go to pull my second bill, all that's left in there are 4 $1 bills. If I pull a 1 first, then there's a 5 still in there and 3 $1 bills. If I pull a different one, it's the same thing with a 5 and then 3 $1 bills. Okay, so there's our tree diagram. Here's our first pull out of the bag, and then here's our second. What is the theoretical probability of getting $6? So we have 1, 2, 3, 4. 1, 2, 3. So we have 4 times 5. So we have 20 possible outcomes, right? My probability of $6 out of that 20, how many times am I going to get 6? Well, 1, 2, 3, 4, 5, 6, 7, 8. So 8 out of those 20 times are $6. What's my probability of getting $2? Still out of 20. Now, if I pull a 5 first, I have no way to end up getting $2. But if I pull a 1 first and I pull a 1 on my second pull, then I can get 2. So I'm going to count up all of my possibilities that are a 1 and a 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that means if you look at this, I have 8 here and 12 here. That's all of the possible outcomes. So I can either get I can get $6 8 times, or I can get $2 12 times. What's the theoretical probability of getting $3? Well, do you see $3 as a possible outcome anywhere up there? I sure don't. So no chance of getting $3. Would you rather that your grandmother give you $4 per job or use the bills in the bag? Now, for this question, if you are an on level, you can answer this question as long as you are able to support your answer. You will be fine. Advanced, there will be an additional video, or I will explain this question to you, and we'll talk through how I want you to